So today we're going to wrap up our unit on chemical reactions. We're going to talk about something called complete ionic equations and net ionic equations. So we're going to look at what's actually doing the reacting during a chemical reaction in some of our single and double replacement reactions. Okay. So first, we're going to start with just the complete ionic equations. What word do you see in ionic? Ion, okay? So in complete ionic equations, all we're going to do is show the dissolved ionic compounds as their free ions. Okay? And to really understand this one, you probably want to copy down the example, and then we're just going to continue on with the same example. So here we have this example. We have silver nitrate plus sodium chloride gives us silver chloride and sodium nitrate. Okay. If it's aqueous, what does that mean? Okay, it's soluble. That means it's going to dissolve in water. So if we look at silver nitrate here, when it dissolves in water, it's going to break up into silver ions, and then it breaks up into nitrate ions. Okay, so all we do is take these compounds, if they're aqueous, we just break them up into their individual ions. Next, we have sodium chloride, and again, do you see that it's aqueous? Okay, so then we just break it up into sodium ion and chlorine ion. Our first product is silver chloride. Do you see how it stays together and is a solid in solution? Okay, we keep that together down here also. So you don't break that one up because it doesn't become an ion. Okay. And then last we have sodium nitrate. Again, it's aqueous, which means it breaks up into sodium ion plus the nitrate ion. Okay, so then down here, this longer equation that's showing all of the ions, this is the complete ionic equation. And then we're going to build off that, so it's worth your time right now. Go ahead and copy it down. So when we look at that complete ionic equation, we have something called spectator ions. Okay. And let's say you go to the basketball game today, and you're a spectator. What are you doing? Okay, you're just watching from like the side, right? Are you actually participating? Okay, so the spectator ions, that's basically what they're doing. They're just kind of hanging out and spectating. They're not actually participating in the reaction. And so how we can identify these spectator ions, they're going to be ions on both sides of the reaction. And what that means is they're going to look identical on the left side and the right side. So then if we look at the example, this is the same example you just wrote down. Okay, so there's no need for you to rewrite this. This is what you just wrote down on the previous slide. Okay. You just go through. So on the left side, do you see how it's silver with a +1 charge? And on the right side, do you see how it's now silver bonded to chlorine? Does silver look identical? Okay, so no, it's not a spectator ion. Then we move on to nitrate. Do you see how it's NO3 with a -1 charge on the left, and then it's NO3 with a -1 charge on the right? Okay, do those look identical? Yes. So then, yes, that is a spectator ion. So I'm just going to highlight them for right now. Okay. Then we have sodium with a +1 charge and sodium with a +1 charge. Do those look identical? Okay, yes. So yes, those are spectator ions. And finally, we have chlorine with a -1 charge and then chlorine bonded to silver. Do those look identical? No. So then those are not spectator ions. So then before I move on to the next slide, I'm going to show you it on this slide first. So then we use spectator ions to help us get us to something called the net ionic equation, which is like the good stuff. So what are the reactants that are actually reacting? Okay. So now that we've identified our spectator ions, just draw like a little line through them. So then our net ionic equation is what's left over. So if you cross out your spectator ions, it's everything that's left behind. So then now if we cross out those spectator ions, all we're left with is the silver ion plus the chlorine ion gives us silver chloride. Okay. And then this again, this is like the good stuff, right? So these are the reactants that are actually reacting in the product that they're making. All right, so then the last step is you just have to make sure everything is balanced. So elements have to be balanced. And this time, since we're looking at ions, charges also have to be balanced. Okay. So on the left side, we have 1 silver. How many silvers are on the right? Okay, 1. How many chlorines are on the left? Okay. 1. How many are on the right? 1. Okay. And then your charges also have to be balanced. So on the left, we have 1 positive charge and 1 negative charge. What do those come out to be? Neutral, right? They cancel. And on this side, is there any charge? So again, neutral. Okay, so now we're just going to do 2 practice problems. The first one is going to be a single replacement reaction. So you see one of those, and then the second one will be a double replacement. So go ahead and copy down the equation listed here. Make sure you take the time to write the solids and the aqueous ones also. Okay, so the first thing we're going to do is write the complete ionic equation. So this is like the really long one. Okay. If we look at the original reaction, if it's solid, you're not going to change anything. Okay, so I'm still just going to write lead, and it's a solid. Okay. And then we have the silver nitrate. If it's aqueous, this is when we're going to break it up into the ions. Okay, and it's already been balanced, so I'm going to keep it balanced. So it breaks up into 2 silver ions. So I'm going to write 2Ag. And then if you look at the back of your periodic table, what is the charge of Ag? Okay, so it's +1. Okay. And then this 2, it also distributes to the nitrate. Okay, so I'm going to write 2 nitrates, NO3. And again, if you look at the back of your periodic table, what's the charge of nitrate? -1. Okay. Then we get to the silver, and it's solid. So I'm not going to change anything. I'm going to copy it exactly how I see it. So we get 2 silver atoms, and they're solid. And then we get to the lead 2 nitrate, and it's aqueous. So that means I'm going to break it up. So we get the lead ion. Okay. And if you look at the back of your naming chart, what are the options for charges for lead? Okay, it could be 2 or 4. So how we know the charge, let's look here. If we were to undo the crisscross rule, so we bring this one up here, what charge would lead have? Okay, so we know this is going to be the lead with the +2 charge. And then how many nitrates are here? 2. So watch this. I'm going to take this little 2, and I'm going to make it a coefficient. So we're going to have 2 nitrate ions. Okay, are you with me so far through this step? Okay, the log one is the complete ionic. Okay, so it's showing all of the ions. So we really want to get to the net ionic though, or just like what are the things actually reacting? So now we're going to go through and we're going to cancel out those spectator ions. Okay. So on the left side, we have solid lead with no charge. Then we have lead that does have a plus charge. Are those identical? Okay, no. So those are not spectator ions. Okay. We have silver with a +1 charge and then solid silver with no charge. Are those identical? Nope. Here we have 2 nitrates with a -1 charge, 2 nitrates with a -1. Are those identical? Yes. Okay, so you can cross out the nitrates. And so now we're just going to rewrite the reaction with everything that didn't get crossed out. And then what we're left with, that's what we call the net ionic equation. Okay, so that's really the stuff that reacts during the reaction. And then your final step should just make sure that everything is balanced. So how many leads do you have on the left side? 1. How about the right side? 1. How many silvers on the left?
2.
And how many on the right? 2. Okay. And then last step, charges also have to be equal. So silver has a plus charge, but how many are there? 2. So the left side has a +2 charge overall. What does the right side have? +2. And so are those the same? Good. Okay, last example. This one's a double replacement reaction. And we're going to practice predicting our products together. So we're going to start with barium hydroxide. And the iron 3 chloride. Okay, so for this one, I didn't give you the products. So that means we have to predict the products on our own. What two elements are going to swap places? Okay, so we're going to swap the barium and the iron. Okay, so I'm going to just write their formulas off to the side. So iron is going to bond to the hydroxide. If you look at the back of your periodic table, what kind of charges can iron have? Okay, 2 or 3. So then we have to look at the iron 3 chloride to figure it out. If you were to undo this crisscross rule, what charge would iron have? Okay, so we know it's going to be iron with the +3 charge. And then if we look at hydroxide, what charge does hydroxide have? Okay, so when we crisscross, what should our formula be? Okay, Fe, and we're going to add the parentheses. All right, and then our second elements that combine is going to be the barium and the chlorine. What's the charge of barium?
2.
Okay, barium's a +2. What about the chlorine?
1.
Okay, so when we crisscross, what do we get for the barium chloride? Do y'all agree?
Yeah.
Okay. Okay, what's our next step? Good. Okay, so we're going to figure out if it's aqueous or solid using our solubility charts. So let's do the iron hydroxide first. So on your chart, go down to find hydroxide. And is iron any of those ions listed? Okay, nope. So drop down to the next row to any other cation. So what's the solubility? Okay, insoluble, so we're going to write S. It's going to make a solid. And then now let's look it up for the barium chloride. Okay, so go to chloride. And is barium one of those listed ions? Okay, so it drops down to any other cation. What's that solubility? Okay, soluble, so we're going to write AQ. Okay, does a reaction happen? Okay, yes. So what's our next step? Balance. Okay. Start with the hydroxides because those are going to be the most complicated. How many are on the left side? 2. How many are on the right side? 3. What's a common multiple between 2 and 3? Okay, so let's try to take both sides to 6. So then what coefficient would we have to add here? Okay, so we're going to put a 3 there. And then what do you have to add on this side? Okay, so we'll put a 2 over here. And then I'm hoping everything will kind of flow nicely from here. Okay. So then now we have how many bariums? Okay, 3. So what do you need on this side? Okay, so let's put a 3 there. And then that also changed our chlorines. So we have 3 times 2, which is 6. So what do you need over here? Okay, so let's put a 2 there. And then that changed our irons to 2. And how many do we have over here? 2. Okay, are we balanced? Good. Okay, so then our first step, we're going to write the complete ionic equation. This is going to be the really long one. Okay, so write small. I'm going to write small up here because I want it to fit on one line. Okay. So for that complete ionic, we're just going to look. If it's aqueous, we're going to break those up into their ions. Okay, and if we balanced it at the beginning like we did, if you can carry your numbers throughout, then it'll be nice and balanced for you at the end. So barium hydroxide is aqueous, which means it's going to break up. So it's going to break up into 3 barium ions. And then what's 3 times 2? Okay, 6. So I'm going to write it as 6 hydroxides. And I'm just going to put that 6 as a coefficient. Then we have the iron 3 chloride, and it's aqueous. So that means it's going to break up. Okay, so I'm going to break it up into 2 irons. And we already established iron's charge is +3. And then what's 2 times 3? Okay, 6. So I'm going to write the 6 chlorines, and again, I'm just going to put 6 as a coefficient. All right, then the iron 3 hydroxide is solid. So I'm not going to touch that one. I'm going to rewrite it exactly how we see it up here. So I'm going to keep the 2 there. So it's 2FeOH3. And then finally, we have the barium chloride, and it's aqueous. So that means it's going to break up. Okay. So we have 3 bariums. And then what's 3 times 2? Okay, so 6. And I'm going to write that as like 6 chlorines. Okay, so this really long one, that's what we call the complete ionic. So like if we could see these little ions floating in solution, this is what we would actually see. And then we really want the net ionic, so what's actually reacting. So our next step is to cancel out those spectators. So on the left side, we have 3 bariums with a +2 charge. On the right, we also have 3 bariums with a +2 charge. Do those look identical? Okay, so if they're identical, we're just going to cross them out. Then we have 6 hydroxides, and then hydroxide bonded to iron. Do those look identical? Okay. Nope, so it's not a spectator. We have 2 irons with a 3+, and then iron bonded to hydroxide. Are those identical? Okay. Nope, not a spectator. 6 chlorine with a -1 charge, and then 6 chlorine with a -1 charge. Okay, so what are we going to do with those? Okay. So then now I'm just going to rewrite my equation with everything that didn't get crossed out. So our 6 hydroxides plus our 2 iron ions is going to give us 2 iron 3 hydroxides. And then if you balance it at the beginning and you keep track of your numbers throughout, this should be balanced for you at the very end. So now let's just confirm. So we have 6 hydroxides on the left side. What's 2 times 3?
6.
Okay, so 6 on the right side. We have 2 irons on the left, 2 irons on the right. And then we also look at charges. So we have 6 negative charges. And then what's 2 times 3?
6.
Okay, so we have 6 positive charges. So what do those charges do? Okay, they cancel. And are there any charges on this side? No. Okay, and then last, if you just need to label your notes, your condensed version is called the net ionic. And your really long version is the complete ionic.